we can go ahead and get started. Thank you everyone for joining. My name is Shava Smallen, and I'm one of the co-PIs on the Cloudbank project. And we are very happy to host a webinar with Microsoft on their OpenAI toolkit. So just a few housekeeping rules. We will be recording this webinar and we'll post it later on our website. So if you have to leave early and want to catch up later, just check our website for the posting. And then if you have questions, you can post it into the Q&A chat icon. We will try to answer questions as they come in, but if something is require more time, we'll leave it for the end and answer as many as we can. And I think that's the mains there. So Cindy, next slide. So here's the agenda that we have for you. So we're going to start off with a quick introduction on the Cloudbank project that Rob will give, and then we'll hand it off to the Microsoft folks. We've got Charles Rice here, and then we wanted to give a chance for one of our existing researchers to talk a little bit about his experiences using OpenAI. So we have Mohit Iyyer from UMass. And then we'll leave the rest of the time for questions. So with that, I will hand it off next to Rob. If you can do next slide, Cindy. Thank you.
Great. Hi there, everybody. My name is Rob Fatland. I'm at the University of Washington, where I'm a research computing director. And like you, I'm just as anxious as you are to move on to the OpenAI portion of this webinar. But this event is sponsored by Cloudbank, so we wanted to take just a moment to let you know what the story is for the Cloudbank organization. So Cloudbank is a collaboration between UC San Diego, University of Washington, and UC Berkeley, funded by the National Science Foundation. And our purpose is to basically facilitate cloud computing as an approach to research computing. And we're specifically focused at this time to do that in the context of the Computing Information and Science, the CISE Directorate at the National Science Foundation. So let's do the next slide then. We started this project 5 years ago with sort of a survey of researchers. Why do you or don't you use the cloud? And we saw a lot of common trends, but they basically center around cost and approachability of cloud computing. So we decided to address that with this program. And as it's evolved, let's move on to the next slide. As the program has evolved, our funding model has also kind of changed to meet the demands and the approach to computing that the faculty members bring to using the cloud. So what we do is we provide a means of accessing 4 different public clouds. Those are listed in the cloud thing there: the Amazon Web Services, Microsoft Azure, IBM, and Google Cloud Platform. We facilitate account management and financial operations so that a research team that's coming through the Cloudbank organization has access to the cloud and can track how much they're spending. In addition, we're providing through the UC Berkeley Data 8 Stack classroom tools. And then we provide training, and we have help desk support and so forth. And it's probably important to mention that because of our financial arrangements, particularly UC San Diego, there's no indirect costs charged on cloud use. So that sort of overhead goes away. And that's a big part of what we bring to the cost management aspect of using the cloud. Next slide. Let's see. So the approach to getting funding through Cloudbank is to fill out this form here. You'll notice that down at the bottom right of this slide, it says www.cloudbank.org. So that's our portal. That's how we grant access to different clouds and provide all the other background information that Cloudbank hosts. And so this slide just sort of describes the process. It's a fairly lightweight process. to apply for cloud support, and it is evaluated within a few weeks. And our support levels range anywhere from as high as 100K all the way down to just a few K, and it's always done on a shared resource basis and based on the researcher expressing the kind of cloud support, the need that they have. Next slide. Okay, so this is a quick little look at cloud computing as a approach to research computing that will or won't work. There's all kinds of great aspects of the cloud. For example, power, light, air, temperature, gravity, and so forth are all provided. You don't have to build a data center. Indirect cost waiver, as I mentioned, and egress costs are covered also, so that goes away. But then the main, of course, advantage of the cloud is the vast capacity of the cloud to provide computing, storage, and networking. But computing, storage, and networking is just really the ground floor of what using the cloud provides, because built up from that is a vast network of different kinds of services that you can also take advantage of. Now, the downside of that is you have to learn how to use the cloud. So this is not a free lunch kind of a pitch. There is a learning curve involved. And if you don't go through that successfully, then you're at risk of being an inefficient cloud user, and that can drive up your costs. So Cloudbank, together with the vendors that we work with, and together with the abstractions that are available out there, we're about facilitating the researcher learning about and using the cloud in an effective, efficient way. Next slide. Okay, and this slide is just a call out to the Berkeley component of our teamwork and how they are also supplying curriculum materials, and in particular building out on the cloud like a Jupyter notebook environment that supports data science learning and can do that at scale to several thousand students. Next slide. So I think this is my last slide. At the moment, we are supporting 336 NSF-funded projects. The spend chart is at the center right there, and time is from left to right. And dollars spent per month is the vertical axis. So you can see that we're spending in the ballpark of $300,000 a month right now supporting these 336 different projects. And the total amount of access we've provided so far is 200 project years. So next slide. Okay, so with that, I've introduced Cloudbank, and happily we can pivot now to Azure OpenAI, and I'll be quiet.
Thanks, Rob. Hey, everybody. Charles Rice. I'm a principal data and AI specialist for Microsoft based out of Austin, Texas. I'm here to talk about Azure OpenAI and sort of like what the differences are between OpenAI.com, Azure OpenAI, and perhaps why you should consider using Azure OpenAI or OpenAI itself. Next slide, please. So there's a very tight relationship between OpenAI and Microsoft. OpenAI started back in 2015, I believe. They started off as an open source nonprofit organization and quickly found out that it was hard to attract the talent that they needed to crack the code for artificial general intelligence. So in 2019, they spun off of a fixed cap for-profit entity, so they could create enough revenue and profit to hire the talent that they needed to crack AGI. And because of that, it gave Microsoft an opportunity to invest in that fixed cap for-profit organization. So in 2019, we invested $1 billion into OpenAI, and OpenAI then made Azure the platform that OpenAI runs on. Fast forward to late last year, I think November 2022, we made an additional investment of $20 billion that gave us a even tighter partnership with them. So Microsoft now owns 49% of OpenAI. That plus the fact that OpenAI all runs on Azure anyways makes us sort of agnostic as to whether you use Azure OpenAI versus OpenAI.com. However, there are very good reasons to use Azure OpenAI versus OpenAI.com, and I'll illustrate those here in a second. But can you go ahead and proceed to the next slide? So as you can see on the bottom, these are the models that are available from Azure OpenAI. So we have model parity with OpenAI.com. We're usually a few weeks behind. They usually come out with a model first, and then we wrap our enterprise-grade compliance and security and SLAs and all that good stuff around the models that they develop, and then make them available in Azure OpenAI. So going left to right, we have GPT-4 and GPT 3.5. Those are the text generation models that help you not only generate text, but make sense of text. Next, we have the chat completions API that takes the GPT-4 and GPT 3.5 models and makes them into a sort of a conversational chatbot. We also have an embeddings API that you can use to vectorize your text into embeddings vectors for that natural language processing. We have DALL-E 2. DALL-E 3 is right around the corner to generate images. And most recently, I think this past week, we announced the availability of Whisper, or the text-to-speech, speech-to-text and translation model in Azure OpenAI. Next slide, please. So there's OpenAI is just one of many AI services in Azure. So at the very foundational level, all of them are developed using Azure Machine Learning Service. That's sort of there at the bottom of the slide. We have different domains for the cognitive, what we call cognitive services models in Azure. We have vision, speech, language, decision, and OpenAI is yet another domain that we have as AI as a service, so AI as an API. We use those AI as a service to develop products, Microsoft products. So as you go up from the bottom to the third row, you see that we use those vision, speech, language, decision, and OpenAI models to create things like Azure Bot Service, Azure Cognitive Search, Azure Video Indexer, and others. And additionally, we build on top of those to create services like Power BI, Power Apps, Power Automate, and Power Virtual Agents. And then finally, we wrap those all around to Microsoft 365, Microsoft Dynamics, any partner solution, and any other products that customers may develop using those products. So that's sort of how the hierarchy of AI services, AI and ML services in Azure works. Next slide, please. So one thing that comes up often when I speak to customers about using Azure OpenAI or LLMs in general is the fear that the data that they send as part of their prompt to the APIs becoming part of the models. One of the differentiators of Azure OpenAI is that it's enterprise grade, and your privacy is our #1 priority. So just to make it crystal clear, your data is your data is your data, end of story. Your data is not available to any other customer. It's not available to OpenAI, the organization. It's not available to improve any OpenAI models. It's not used for by Microsoft to improve any other product, either our products or any third-party products. It's also not used automatically to train models, Azure OpenAI models that you own as part of your resources in Azure. And finally, we have the ability to fine-tune the foundational models like GPT-4. When you do fine-tune those models, your data does become part of that fine-tune model, which is like a Lego brick on top of the foundational models. That fine-tune model is your IP under your own lock and key, under your own encryption keys, and exclusively for you to use. So there's no one at Microsoft has access to your data, whether it's the prompts and completions being sent back and forth to Azure OpenAI or the fine-tuned models that you create on top of the foundational models. Next slide, please. Additionally, I have a lot of conversations with academic medical centers across the country. One of the big ones that comes up with them, obviously, is HIPAA compliance for PHI or patient information that gets sent to these models. Azure OpenAI is HIPAA compliant, so if you have an existing BAA agreement with Microsoft, you can use Azure OpenAI and be rest assured that your utilization of Azure OpenAI is within compliance of HIPAA. We will need to put up the guardrails to make sure that the configuration is in place to abide by HIPAA, but the service itself is attested to HIPAA. Next slide. And additionally, Azure OpenAI and Azure Public Cloud is also FedRAMP High and DoD IL2 authorized. So this is very important for NSF and DoD grants that have these specific requirements for like CUI type research. Azure OpenAI and Commercial Cloud is FedRAMP High compliant. And with that, I'm going to take over the screen and just show you a quick example of something that I believe will be useful to researchers, especially NSF researchers, using the Azure OpenAI server, just to sort of show you the art of the possible and how quick it is to use the service. So I'll share my screen. And I believe y'all can see my screen. So this is the Azure portal. I'm going to click on Azure OpenAI up here in the recent services that I've used. As you can see, I have several instances of Azure OpenAI. These are all private instances for me, private API endpoints that I use and only I can use. or anyone in my organization if they have the appropriate permissions. I'm going to click on this instance of Azure OpenAI that I have deployed in Canada. I'm going to click on Explore. This is going to open up a new tab and take us to the AI Studio. This is what we consider the playground. This is where you sort of develop your, play with the API parameters to develop your solution, take it from there, and then develop it further in IDE for your application. Top down. So the playground is where you can get into the chat interface. The completions are just API responses back and forth in DALL-E, so you can generate images. Down further, we have the ability to look at the different models that are available to Azure OpenAI, create deployments of those models. So take the models and create an API endpoint that you can target and hit to do inference on. And then the ability to upload data for fine-tuning of the models, and the ability to create content filters, so you can filter away things like hate speech, sexual information, violence, and self-harm, I think are the categories that are caught by the content filters. I'm going to pop into the chat. And this is just GPT-4 as is. So this is GPT-4 based on the corpus of the internet through 2021. So I'm just going to ask it a question that it should know based on its knowledge of the internet. So I'm going to ask it, what was the land speed record in 1956? Let it do a little bit of inference on that. So land speed record in 1956 was 394 miles per hour. That's great, but about 100% of the customers I speak with about using OpenAI want to use Azure OpenAI with their own data. And as you can see, we have the ability to, first of all, set a system message. This will tell it who it is, how it's supposed to behave, what it's supposed to do, what it's supposed to not do, what its personality is, and also the ability to add add your own data to the model. So now you can have a conversation with your own institutional or research data. So first thing I'm going to do is set the system message. I'm going to open up Notepad++ because I have the system message set up here. So this is the system message I'm going to use. So your name is Grant GPT. You're a friendly and helpful grant writing assistant tasked with helping principal investigators write research grants and grant proposals, receive feedback on their proposals, and answer questions on NSF's grant writing guidelines. You've been grounded on the NSF's grant writing guidelines, and that is the only source of data that you're allowed to use to answer your questions. This part is important because, first of all, I guess I misspelled guidelines there. That doesn't matter. But this part's important because you're telling it to only infer information to answer your question based on the information we provided. Don't use the corpus of the internet. Forget what you know about the internet. Only use the data we're about to provide you to answer the question. If there is not enough information, say you don't know. If asking clarifying questions to the user would help, ask the question. So I'm going to copy this in my clipboard. I'm going to paste it here to set the system message and hit save. And now it's going to reset the cache, if you will. I'm going to ask it the same question, and it may still work because I haven't provided data, but it should. Okay, there you go. So I'm sorry, but as an assistant grounded on NSF's grant writing guidelines, I don't have access to historical data records, such as the land speed record. So now we know that it's working. It can't answer questions other than what the NSF says are grant writing guidelines, but we still haven't provided the data to it. So I'm going to go to add your data, add a data source. And just to show you what I'm going to be uploading here in a second, my downloads folder, I have the NSF's proposal and award policies and procedures guide. It's a 203-page PDF that I guess the NSF publishes to help you all write your grant proposals. So I'm going to upload this file to Azure OpenAI. So I'm going to select the data source. Blob storage, this is our generic object storage in Azure. I've got a storage account already. Let's tell it to use the NSF's docs storage container. So I've already uploaded that PDF in that doc into that container. Cognitive Search Index. So Cognitive Search is our search engine as a service. Sort of behind the scenes, what it's going to do is it's going to look into that storage account, grab whatever PDFs are in there, or use OCR to extract the text from the PDFs, and then index the text into the search index. And then it's going to apply some logic to create chunks. So OpenAI does have a limitation of what's called a context window, of how much information it's allowed to ingest per API call. So we need to break up that 203-page document into different chunks so we can give it bite-sized chunks of information relevant to the user's question, right? So associated with the cognitive search resource, give it a index name. So this is where it's already created this one. That's why I'm adding the integer 2 at the end of it. Then I can do things like adding vector search to do like cosine similarity to get more relevant search results based on the embeddings output of the embeddings API. Hit next. I'm going to search type. I'm going to do hybrid plus semantic. So this is going to be vector search plus semantic search. So just enriched data search relevance based on not only cosine similarity, but also the semantic meaning of what the user is asking, and also the context of the documents. For example, I guess the example I like to use, time flies like an arrow, fruit flies like bananas. So like the words like and flies in both of those sentences are very different depending on the semantic meaning or the context of the sentence. So that's why we want to enable things like semantic search and vector search to get better relevance based on the context. I acknowledge there's additional charges for those. Hit next. Save and close. I'm going to skip saving, or actually no, I'm going to go ahead and do this. And now you can see it's ingesting. Now it's going to do that logic where it goes in, grabs the file, does the OCR text recognition to ingest it into the cognitive search index. This does take a couple minutes, but I think I'm doing okay on time. Let it churn through that. While that's doing that, I'll show you what it looks like behind the scenes. So since I already have cognitive search set up, I'll find the index that I created earlier, which is this one. So it took that 203-page PDF that I showed you all earlier and created 243 chunks. So a chunk, again, is that bite-sized chunk of data that the OpenAI API can ingest. So I'm going to hit search. You can see the information. This is just a star.star search, so it's searching the entire cognitive search index. So this is chunk number 102. So this is the 102nd chunk of this PDF. This is the string value of this content of this chunk. So this is just whatever words happen to be in that chunk. It also provides file information, so we can refer back to the original file always. So nsf23_1.pdf, and also the URI to the PDF, so I can link to the document. A unique ID, we just need a unique ID for the cognitive search index. The version, so last updated, since we can tell it to keep looking at this storage account on a schedule, it's good to have a timestamp on there so it knows when this was last updated. And finally, this is the vector content of that that chunk. So this is the vector representation of the embedding of that chunk. So this is sort of what's happening behind the scenes, working through all that data right now to generate this index. Still processing. Go ahead and check the Q&A while this is cooking.
So Charles, while you're waiting, there was a question in chat about when OpenAI will be generally available without getting.
Oh, sure. Azure OpenAI is generally available. I think we made it generally available earlier this calendar year. I think early spring it became generally available. But the question also asks without it being a waitlist per subscription. That is independent of it being generally available. That is because Microsoft is very serious about responsible AI, and we want to make sure your utilization of this very powerful service aligns with our responsible AI principles. So we vet every request for Azure OpenAI manually. Ironically, behind the scene, a human is evaluating those requests, those submissions, to make sure you're who you say you are. You are a legitimate Microsoft customer. Your use case aligns with, again, our responsible AI principles, and you need to attest to like special terms and conditions for those. So it is GA, fully supported, HIPAA compliant, all that stuff. But that form you need to submit is going to persist, as far as I know, indefinitely. And you can do 3 subscriptions at a time. All right, so now it's based on our data. It knows the NSF's guidelines. So I'm going to ask it another question. So like, what are the top 5 most? I'm not a PI, I never write grant applications, so I don't know what's important for you all. Top 5 most important things I should consider when writing an NSF grant. Hit enter. I'll close this just to give me some more real estate on the screen. Now it's doing the inference. It's calling the cognitive search index. Now we start to see the completion happening. So top 5 most important things to consider when writing NSF grants are intellectual merit, broader impacts, creativity and originality, planning methodology, qualification and resources. Critically, I don't know if you caught it, but there are citations to these, right? So that's important, especially for research, I think. citations. If we were to expand this references, we can click on this and find the chunk of the document that it used to answer this question. Okay, so now we know that we can trust this information because we have a citation to follow to verify the authenticity of the information it's given us. And finally, the last thing I'll show you, there's on the top right up here, there's a deploy to button here. If you were to click on that and choose either a web app or Power Virtual Agent, the differences are, if you're a true developer, you probably want to go to the web app. If you're more like a hobbyist developer or not a developer at all, Power Virtual Agent is like our no code, low code chatbot as a service. So I would go to web app, give it NSF GPT as its name, choose an Azure subscription to target, a resource group to drop it in, location, I'm in Canada East in this region, in this instance, so I'm choosing Canada East. The pricing plan, so like how much horsepower this app should have. Do you want to enable chat history or not? If you do, there's additional costs. I'm going to say yes, yes, yes. Hit deploy. I'm not going to do it because it takes a good 15 minutes to do that. But once you hit deploy, it'll start cooking in the background and deploy a web app for you. And what you'll get out of the box is this web app that you can then take and iterate off of. So let's give this an MFA request. And I have this pretty GUI that I can have a conversation with on NSF grant writing documents. So I'll ask it the same question. What's inside? Yeah, I can show you this anonymous participant. 1 second. So I can ask it the same question. What are the 5 most important things you should know about writing NSF grants? And now, now I'm outside of I guess the point I'm trying to make this, all this was within the AI studio. So this is like where a developer or whoever manages or owns, administrates the service would live. But your end users you never want to point them to the Azure portal, the AI studio. Your end users would consume it as either a standalone app or an app embedded into your website. So I asked it the same question. Different answer. I'm not saying it's the wrong answer, but it's just the nature of how LLMs work. It's all probabilistic, non-deterministic. So the answers you'll get are going to vary from one interaction to another. So you can see what are the 5 most important things I should know about NSF grants: reporting, project outcomes, report for the general public, page limitations, results from prior NSF support, scientific integrity. So maybe not different answers, just different sort of wording or interpretation. And again, critically, and especially for research, we have citations throughout its claims that I can click on and follow to get to the chunks it's referring to, so I can validate and verify the authenticity of what it's saying. To answer the question in the chat, could you show how to create an instance of GPT-3 or 4? Yes, I can. So, and someone tell me how I'm doing on time. I'm not watching the clock.
You have about 7 minutes left.
Oh, perfect. Okay. So within Azure OpenAI Studio, you can see I've got deployments and models here. If I were to click on models, I see all the models that are available for this instance of Azure OpenAI. And by the way, they vary from region to region. This is in Canada East. If I were to go to, let's say, East US instead, for example. 1 second. Now that you told me I've got 7 minutes, I'm going to take my time not to rush through it. If I were to go to East US and click on models, you'll see, I think, yeah, I have a lot more models here, a lot older models here. We sort of depreciated like Text Da Vinci and Babbage and Ada and settled on GPT 3.5 and 4. That's just to show you the differences between, that's why the region matters where you deploy, because 3.5 16K June 13th version, for example, is not available in every region, as is Text Da Vinci 3, for example. All right, so these are the models that are available to me within this instance of Azure OpenAI, but this isn't your deployment of it. So now we need to create what we call a deployment. So I'd click on GPT 3.5 Turbo 16K. 16K is the context window I was mentioning. It's how much information it's allowed to hold at once. Hit deploy, give it a deployment name. I always like to be as literal as I can, including the version number 0613 and also the region. So I know which model, which version, and which region, and I guess which, like what the context window is. So when I'm interfacing this with like Python or the API calls, I know exactly what I'm doing or what I'm interfacing with. Advanced options, tokens per minute. This is how many tokens you can send it within a minute, pretty literal. So I just crank this up all the way to the right if you have the capacity and hit create. And now it's creating the actual deployment. So if I go so we've been working in models. If I go to deployments, you'll see I have a few deployments here. I have my GPT-4 8K June 13th, 2000 or June 13th version. I have my embeddings, Ada 002, Canada East 02 deployment, so that I can do things like vectorized text or create embeddings based on my text. And I have the brand new deployment I just created with GPT 3.5 Turbo. But now you may be asking, like, how do I use this? So if I go to completions, I can, what's going on here? Load an example of, why can't I? Let me try this other region. I go to completions. Okay, I can load in my model here. So GPT 3.5 Turbo 0603. And I can say, let's do like, I don't know, natural language to Python. Write a Python function. This is just an example, like a baked in boilerplate example. Hit generate. Okay. But anyway, so to use this in, say, Python now, for example, I can go to view code and get the Python code that I can then dump into Jupyter, for example, and iterate off of, right? This is sort of just to get you started. So Python is there, C# is there if a C# developer, curl is there if you want to just do API calls from your application. So it's sort of quick start. Also, all these parameters on the right-hand side, these are all the API parameters. So you're able to sort of manipulate these, like temperatures, sort of how like quote unquote creative is allowed to be, to get different results here. Let me see if I change this to code, generate. It should work. Yeah, there you go. So there's your function. Hopefully that answered your question. How does this scale to a large corpus of documents, e.g. thousands of scientific papers? So the way it works, the chat completion, or what I was showing you earlier, the OpenAI on your data, is that it takes the user's question, like what is the top 5 most important things about the NSF grant, and then it sends that to Azure Cognitive Search. Azure Cognitive Search then uses the vector search and then semantic search to make sense of the question and also to find the most relevant chunks. So it could, we uploaded one PDF, it could have been 1,000 PDFs, but to find the most relevant chunks against all that data and inject that into the prompt. It's called RAG, or Retrieval Augmented Generation, so that OpenAI has the data to answer the question with. So this is scalable to thousands of documents as is. Where it gets kind of squirrely is things like the context window. If like your document, you're like the meaning of your document is such that you need all the information together, like a chunk wouldn't suffice, then you need to have a conversation with someone like me to figure out a better way to do it. But otherwise, as is, it could be like petabytes of data in that storage account that Cognitive Search can sit on top of and find the most relevant documents and feed it to OpenAI. For the models, are all of these supported by OpenAI, or do we need to have fine-tune? So all of these are the foundational models, 100% compatible with OpenAI's implementations of them. They're not fine-tuned as you see them. We do have the ability to fine-tune models, so I could, I don't have it enabled in my subscription, but you see this create a custom model here. This is where you go and fine-tune a model on your data. However, we've seen close to 90% of the use cases satisfied by this on your data piece. This is like an alternative to fine-tuning, a much cheaper way than fine-tuning, sort of inferencing on your data without having to fine-tune a model, because there's a lot of cost involved with fine-tuning and a lot of complexity, additional complexity of fine-tuning that this does not have. So I would try this method first, the retrieval augmented generation. And if this doesn't work, then we can have the fine-tuning conversation. I've been using OpenAI to develop chatbot authoring tool. I'll put these on the screen, so I guess we're being recorded so everybody sees them. Authoring tool that is capable of using its only content that have been using LangChain for embeddings and storing vectorized database locally. Are there any advice about or against in favor of current approach? So everybody's using LangChain. Vectorized database. So that's where it matters. So compliance reasons, like should you run your own vector database on your workstation, or should you put it in like a compliant behind compliant infrastructure? Azure Vector Search is built into Azure Cognitive Search. That's our vector database as a service. That's what you saw earlier when I was querying. You saw the vector output. That's all HIPAA compliant. That's all FedRAMP high compliance. So that's an easy way to get your compliance without having to worry about what's your workstation or server connected to. Python code, is there an open? Yeah. Okay. Oh,
yeah.
sorry.
Can we switch back to the slides, and then maybe you can answer questions on the chat.
I'll answer. Yep, no problem. I'll answer.
Or save them for the end, but we'll go ahead and switch back to the slides and give Mohit a chance to tell us a little bit about his experiences using OpenAI. So thank you.
My pleasure.
All right. Yeah, so my name is Mohit. I'm a faculty member at UMass Amherst, and my research focuses on natural language processing with a primary focus these days on doing research with large language models. So of course, it is great to be able to access OpenAI's models and, not just OpenAI's, but other cloud providers as well via Cloudbank. So if you can go to the next slide. So I just wanted to start with some motivation from the researcher's perspective. So these large language models like GPT-4 and so on, they are enormously expensive. So if there was like an open source equivalent to GPT-4, most universities would not be able to even run this model at inference time. So like what Charles was showing on the screen, just prompting the model and getting outputs, would be infeasible for, I would say, the vast majority of universities based on their computational resources. So as an example, UMass as a whole has 80 A100 GPUs currently active for the entire university. And, there's like, I don't know how many grad students, many of them want to do research on large language models or other GPU intensive workloads. There's a lot of competition for these limited resources, and it's very difficult to do research in this field where the models are so compute hungry. So Cloudbank and the OpenAI service enables access to this OpenAI studio that allows us to, prompt these cloud-based models like GPT-4 without paying enormous costs. There are also compute nodes for training, which I'll get to a bit later. All right, next slide. Okay, so I guess we don't need to go through the whole overview of what the OpenAI Studio does. I just want to share my personal experience here. So after I got access to Cloudbank, I applied for access to the OpenAI Studio using the Azure credentials that we get through Cloudbank. The models, at least when we got access to them, were not exactly the same. I mean, they're the same base model, but there are different filters and quotas from between the OpenAI Studio models and the OpenAI official API. So we had to further submit requests to remove some of these content filters. They can be annoying even when you're trying to do like legitimate research and maybe you want to, summarize a book or something, and the book contains some objectionable or content that is deemed objectionable. The model may just not produce any outputs. So we had those removed. We, after requesting, got the quotas and rate limits increased, and now the service is actually very usable for us. It's preferable actually to the official OpenAI API. So Cloudbank gives us, some number of credits, and we have spent the vast majority of our credits on the OpenAI Studio service. All right, next slide. So we got access to this in February 2023, and I have a group of about 10 to 12 students, and they have been using it since then for numerous different projects, as our Cloudbank spending should tell you. So I'll just give an overview of a couple of these projects really briefly, and then kind of zoom out to the overall experience. So next slide. So one project that we worked on that we charged the most to our Cloudbank and OpenAI account on was using large language models to summarize very long books. So as many of you know, these models are limited in the size of the text that they can process at any given time. So for example, GPT-4 has a version that takes as input 8,000 tokens max, or 32K tokens. But if you have a very, very long document, like say a novel or something, or just an arbitrary PDF that takes that contains, you know, like hundreds of thousands or millions of words, you can't just blindly feed the whole document into the model. So many people are using these large language models to process these long documents anyway. If you use something like LangChain, they have support for chunking the document into small, manageable chunks, processing each one and then merging. But there hasn't been any systematic study of like what is the performance, the quality of the outputs when you use this chunk and combine strategy. And yeah, as you can imagine, this kind of research is very expensive because it requires sending prompts to one of these large language models that are very long, that basically fill up the context size with every call that you make. And it can be very expensive. So we spent maybe even a little more than $20,000 doing experiments on a variety of different large language models, GPT-4, ChatGPT, different configurations of the chunk size, the strategy to combine and merge. And we were able to, you know, come up with some interesting and useful takeaways for people who want to use these models in this way by doing all of these experiments. So this was a case where this project was really enabled by Cloudbank. I wouldn't normally like to spend that much money on a single project, and certainly not on, like API calls when I could be funding my students, but Cloudbank actually made it feasible to, do these kinds of experiments in a manageable fashion. All right, next slide. So that project was about kind of analyzing the behavior of these large language models and finding strategies to optimize the quality of their outputs for this summarization task. In another project, we shifted our focus to developing different methods to detect whether or not a piece of text has been written by a large language model. So many of you might be teaching and have to deal with, like students using ChatGPT for their homework assignments. And, for many other applications, it's important to at least try to detect whether the text is AI generated. So we developed several different algorithms to detect whether or not the input text is written by an AI. And we benchmarked these algorithms against the language models available on the OpenAI Studio, so GPT-4, ChatGPT, GPT-3, and so on. And here our total costs were about $5K. And we were able to, show that our detection method is more robust to different, attacks that for example, a student might conduct. So they could take the output from a language model and paraphrase it so that it evades a detector. So our algorithms are more robust to these kinds of attacks than other detection algorithms. The things that we developed here are already being implemented by some companies that offer these services. And we actually managed to publish a paper about this at the upcoming NeurIPS conference. So these were two kind of successful projects that really we couldn't have done without the support of Cloudbank and the OpenAI Azure service. So the next slide is, I think, the last one. So I just wanted to close by saying it is awesome to have access to these LLM APIs through Cloudbank. One other thing that at least is important for my own research is training and fine-tuning arbitrary language models, not just OpenAI's. And currently it's very difficult to access the nodes that are needed to train these models, like nodes with A100s or H100 GPUs through the cloud providers that are available on Cloudbank. There's just too much competition for these resources, not enough supply. So I think hopefully we can expand our research to beyond just querying APIs like the OpenAI one to actually renting out some nodes and training models of our own. But for now, the OpenAI Studio has been super helpful for our research. So yeah, that's all. Thank you.
Thank you so much, right? Okay, so there are a few questions left in chat, and if anyone else has a question that they want to pose, please feel free to post it, and we'll probably answer these sequentially. If we are unable to get to everybody's questions today, we'll try to post something in a document later and send it out along with the recording. And so maybe, I think Charles, maybe a lot of the questions are probably you, if you start taking them.
So I think I answered, so the ones, so other than the one at, I think 2:34 p.m. my time, which is 2 hours ahead of yours, like the last one, I think I answered on the call or like when I was presenting, or I answered asynchronously.
Okay.
So to answer the last question, can every user get a customized model by fine tuning, or do we need to get permission and then fine tune? So fine tuning, two different things. Fine tuning Azure OpenAI right now is in private preview, so only a few customers have access to it, or like a few dozen customers really have access to it. I hear public preview will be sometime soon. I don't know when that date is, but we also have, and this is completely separate conversation from OpenAI, but we also have the ability to fine tune things like Llama 2 or a lot of the Hugging Face models in Azure Machine Learning Service. So there's, OpenAI is not the only LLM in town. There's other options, and a lot of them are also within Azure Machine Learning Service that are fine tunable.
Awesome. Okay, and then the next question I can take. So the question was, is my cloud provider, or is basically the Azure AWS tied to my grant? So if you get a Cloudbank allocation, it is usually tied to an NSF award. That's through the model that Rob talked about at the beginning of the talk. We do have some discretionary funds available for smaller amounts, and that does not require an NSF award. So that's available if you want to send us an email at that help@cloudbank.org. But hopefully that answers that person's question there. And then let's see, can we get access to, oh, I have to go there. I think we got that one already. Without being waitlisted. So I think the last question was that you can't, there is always a wait list that you need to request access to OpenAI, just so that they are aware of what it is that you want to do with it.
That's right, but it used to be up to 2 weeks to get access. Now it's like a day, right? So the wait list is very short.
That's great. Okay. I think we've got all the questions. Just taking another pass through. Yeah, are there any other questions folks have? Okay. Well, if you think of something later, just send an email to us at cloudbank.org. If you have something that's very OpenAI specific, you can go ahead and send it to that cloudbank@microsoft.com email, and they'll make sure that it gets to Charles or somebody else from the OpenAI team for them to answer your question. So, and then there on the lower part of the slide is the email, or I'm sorry, the web address to our user portal. So if you are interested in getting access to Cloudbank, you can take a look there. Okay, there's a few more questions coming in for Charles, I think.
I just answered the API one. So yes, Azure OpenAI and OpenAI APIs are 100% compatible. They are the same API. You just change the type from OpenAI to Azure, and that's it. There's another question about knowledge graphs and triples. I'm not sure if that's for me. Unless just generally, you can ingest whatever you want. You may need to coach it on how to understand the structure of the data. If it's like a knowledge graph, like it's really good at like JSON, for example, of understanding JSON schema. But if it's something that sort of out of left field, you may need to sort of walk it through, like what the structure is, what the schema is.
Thank you.
You're welcome.
Okay.